High today around like 24, tomorrow back up to mid 50s. So should see most of that snow melting and stuff like that. So that's how that's gonna go. Miss Hanson, if you didn't know, she had her baby. So yep, Hadley Jane, Hadley Jane, 8 pounds 2 ounces. So that was exciting.
Do you have a picture?
I do. You want to see it?
Yeah.
Sure.
Miss Hanson or the baby?
The baby.
Okay.
Then we watched TikToks about babies being born and how they look stupid afterwards. And then a lot of them get cone head. Have you seen those TikToks? I'll show you.
I don't think I.
Babies aren't always the cutest things when they're first born.
First
They
time.
a lot of times babies kind of look like they needed to be left in the oven for another
Put
3
back in the
months.
incubator.
They look like potatoes.
I like the ones that their heads look like this.
like purple. Literally. Jack was yellow.
You
Oh
know?
my.
Jack can be going a little.
A little spooky box.
They got like a little blue. All those pictures were like purple.
Give them like 3 months.
Richard
It'll buff.
Jamie came out.
Why is Diego? Did he not do the dance?
Huh?
Diego?
Yeah, I guess so. I don't know how his name. I think somebody just threw his name up there. I think that's actually inaccurate.
Oh.
Diego looks like the kind of person who
He
would do the dance.
definitely rock.
There are other people who won't do the dance. Oh, you support him, really? Okay, you declared sides. Well, you might as well declare war. All right.
Just
Might
declare
as well add him
revolution.
to the wall of shame if he agrees with that.
I think that's how that works. You just keep my butt. Yep.
Okay, suppose we got 2 curves and not 1 curve. We're going to learn in this section kind of an introduction to some of the applications, the integral. We've already learned some. This is more of a geometric application. Suppose we have 2 curves, F and G, and we bound them by A and B. And it is going to be our goal to find the area that sits between the 2 curves. Anybody got any thoughts?
I like that color.
Yeah. Thought it'd be rather artistic today.
Does it not work just to take the integral from A to B at the top one and then subtract the integral from A to B at the bottom one?
Exactly. That's all it is. If we were to look at this picture here, and we were to draw a rectangle to represent one of the rectangles within that region, okay? You notice that the height of that rectangle is going to be the top function f of x minus the bottom function g of x. And that's what the height is equal to. How do we find the area of a rectangle? We take the height times the width. What do we say is the width? We say that the width is this infinitely small thing, that we call dx. Therefore, the area of one of the rectangles is very simple. It is the quantity f of x minus g of x, that quantity times dx. We don't want the area of one rectangle, we want the area of an infinite number of rectangles, don't we?
Yeah.
How do we go from one rectangle to an infinite number? You just slap on an integral and bound it from A to B. I mean, that is pretty absurd that we go from a singular rectangle to an infinite number by just using the integral. And now the integral we see as this easy piece in which we just take an antiderivative. Sir?
Do you have to do that, or can you just do the separate integral of f of x and the separate integral and then like subtract the areas that?
It also works out that you could say the integral from A to B of f of x dx minus the integral A to B of g of x dx. So you can break 2 pieces up using subtraction and addition, however. Yep. Traditionally, they'll represent it. If you represent like as on this or as this on the AP exam, they'll give you correct because it is correct. But that's how we tend to represent. So, all right. So let's try a problem. Find the area bounded between y equals x squared and y equals negative 2x plus 3 over the interval 0 to 1. Okay. So for part of the test in this unit, I will give you the graphs so you can see what they look like. And sometimes you'll have to produce the graphs on your own. And that's actually part of what makes this unit interesting is just the amount of review of the different shapes that we have and things of that nature. Y equals x squared. What does that look like?
Parabola.
Nice parabola. So we're going to draw that one first right here. And then I have y equals negative 2x plus 3. What shape does that make? Just makes a line, and it passes through 3. Okay. And in this situation, it doesn't say that we are going to bound it by its intersection points. It says that we are going to bound it from 0 to 1. Okay? So if it said that you wanted to find the area bounded by these two, we would then need to find the intersection points. And that would be like an example 2. But in this situation, we're just looking from 0 to 1. So we're just looking at this region right here. We could look and show that x equals 1 is, in fact, one of the intersection points. But we're not going to. Just trust me that they do intersect at 1. So, once you have this view, you just need to decide which function. Okay.
I was already here once.
Yeah. Little sad that when you were playing your drum thing that you did not pause. When we were all cheering for you, you didn't pause to like wave. Like you looked like one of those English soldiers that
You
like
know,
just
you're not. You're
keeps.
supposed to be straight face. You're supposed to.
Well, maybe you could do it for us.
I was smiling.
Okay.
You broke my rules.
Which one's on top, the parabola or the line? The line. So we say that negative 2x plus 3 is the one that's on top, and then minus the one that's on bottom is x squared. Okay. And so our integral is from 0 to 1 of negative 2x minus 3 minus x squared dx. What? Plus 3, not minus 3. Sorry about that. And now that's not very complicated, is it? I mean, that's just from our past couple units. We simply find an antiderivative. What's the antiderivative of negative 2x? Negative x squared plus 3x minus x cubed over 3. Evaluated at 0 and 1. When I plug in 1, I get negative 1. I have plus 3. And I have minus 1/3. Negative 1 plus 3 is 2. Then minus 1/3. Or 6/3 minus 1/3 is, in fact, 5/3. So the exact area of the purple is 5/3. Not too bad, huh? Yeah, that's it. Okay. It definitely gets a little bit more complex as we move along. Trust me. But this is kind of the basis of the first piece. Okay. Find the area bounded between these two curves. Oh, now they don't give us any bounds. See if you can. What does that graph look like? Obviously, it's a parabola. But can anybody tell me something else about it other than that it's a parabola? It does go through the y-axis at 1. Also, if you look at this, it factors to x minus 1 times x minus 1. So what is the x-intercept? 1. And it's a double root. So you know that it just touches here at 1. So the graph of the parabola looks like that. In most scenarios on the AP exam, they do provide the graphs, but there are times that they don't. Then we have 2x plus 1. Well, as I graph that, I have that kind of a shape. And so we want to find this shaded region right there. Okay? So we'll set it up nice and easy. Which one's on top? 2x plus 1, that quantity minus, and then I have x squared minus 2x plus 1. And if you reduce those, notice how you end up with a positive 4x. What else do you have? A negative x squared. What happens to the ones? They cancel. So that becomes our height. Dx is our width of each small little rectangle. And we're going to integrate from where to where? It doesn't tell us. So we have to figure out the bounds of intersection. How do we figure out those intersections?
Set the two equations equal to each other.
Yeah, we're just going to use a substitution piece. Notice that y is equal to this and y is equal to that. So if y is equal to both of those, then we should say that those should both be equal to each other. X squared minus 2x plus 1 is equal to 2x plus 1. The ones will cancel and we get x squared minus 4x equals 0. Take an x out and I'm left with x minus 4. Does it make sense by our graph that one of the intersection points should be 0? It does. And the other intersection point, apparently over here, is an x value of 4. Suppose I want to know the y value of the intersection, which I don't need, but if I want to know the y value of the intersection, what would I do? Plug it back in either one of these and it will produce 9. So again, because the width was dx, we choose 0 as an x value and 4 as an x value. We stay away from the y values. We'll talk about the y values later on. Antiderivative of 4x. 2x squared. Antiderivative of x squared? 3. I plug the 4 in and I get 16 times 2 is 32. And then I get 64 thirds. I will create common denominators. I have 96 thirds minus 64 thirds, and that produces 32 thirds, which is my answer. Not too bad. We do our last one. Find the area bounded between the curves y equals sine of x and y equals cosine of x over the interval 0 to pi over 4. Work with the person next to you and see if you can draw the region and the represented area first. Okay?
So you put 2 cover sheets on this.
What?
You put 2
Yeah.
cover sheets.
What are you talking about?
Oh, is that what happened?
There's 2.
Was it really?
Yeah. I'm gonna take one out.
No, 3 clean now.
Yeah.
Oh.
Oh, that's what I just did. Yeah. Oh.
Sorry about that. Yeah, try to draw the region first. By the way, my goal over the course of the next 2 days is to cover one more lesson, not to cover 2 lessons. So my goal is tomorrow to cover another lesson and then have time to work on it on Friday. There tends to be a few questions on the assignment, so I'll give you Friday to work. So that way, if you do go to wrestling tomorrow, you have time to get caught up on that.
Thank you. Okay. Perfect.
Okay, show the person next to you what you got. Show them what you got.
Holy cow, that was, wow. I can't draw.
Okay, so the graph of sine of x, what is the period of sine? 2 pi. So I'm just going to draw half of the period. It starts here at 0 and it goes up and it comes back down at pi. Everybody agreed? Whereas the cosine graph is going to start at 1, and it will get down to -1 when it gets to pi. So it should look something like that, okay? So if it says it's from 0 to pi over 4, this spot right here is pi over 2. Hopefully you knew that. The spot where they cross is pi over 4. You could show that's true by setting them equal to each other. I don't see that come up on the AP exam, so I'm not going to go into it too much, but we are looking for this area right here, that exact area. And as you glance at that area, I think it might look, like something was, well, that's kind of an odd shape. How would you even begin by finding that area? Calculus is not afraid to find really any area at all. It works out quite nicely. We have the integral, obviously, from 0 to pi over 4, and it's a dx problem. And so we're going to have the top one, which was on top, cosine of x, and we're going to subtract sine of x. What is the antiderivative of cosine? Negative sine of x. What is the antiderivative of negative sine? Negative cosine. Now, here's where it's interesting, because notice in the previous two problems, I didn't bother at all about plugging 0 in, because they were polynomials. If you plugged in 0, you got 0. But we all know here that the sine of 0 is 0, but the cosine of 0 is 1. So we got to make sure that you're plugging in 0 in this situation. So let's evaluate this. We'll plug in pi over 4. So I get, and I like to separate it into 2 sets of parentheses when I do this, to be real careful. When I plug in pi over 4, what is the sine of pi over 4? Yeah, and then it becomes negative, so negative root of 2 over 2, minus the cosine of pi over 2. Pi over 4, excuse me. Root of 2 over 2. Everybody good with that? Okay, minus, and then the sine of 0 is 0, minus, what is the cosine of 0? 1. So notice as you work this out, negative root of 2 minus, or negative root of 2 over 2 minus the root of 2 over 2, wouldn't that just be the negative root of 2? Minus negative 1. And what do we get? Folks, what's the antiderivative of cosine? Sine. I looked at it and I saw, did you see our answer was going to be negative?
Yeah.
The area between two curves, so long as you're the top and the bottom identify correctly, it will never be negative. So I was like, what's going on? We shouldn't come up with a negative answer. The antiderivative of cosine is sine. What's the antiderivative of negative sine? Positive cosine. So those two are positive.
I was thinking like this, like.
Shame on both of you for not speaking up.
Yes.
Think things are demolishing?
Yep, I agree. Okay, so we're back to it. There's no negative sign of those. We took the antiderivative incorrectly. I will start to second guess every answer you put forth.
Okay.
All right, what is the sine of pi over 4? Root of 2 over 2. Plus root of 2 over 2. Minus the sine of 0 is 0 plus 1. That makes more sense. What is the root of 2 over 2 plus the root of 2 over 2? Just square root of 2. Minus 1.
That's good enough as an answer?
Yes. So this is a problem. I maybe actually pulled this straight from the AP exam. I think this would be when a multiple choice question. That's how they would have expressed the answer. I cannot be clear enough that when this problem comes up, if you get a problem like this on the test, I need to see this piece right here, okay? Including the dx really does matter because there's a difference between dx and dy. Tomorrow I'm going to teach you what dy is. It's a little bit different, okay? The bounds matter. The integral matters. All that stuff matters along the way. So make sure that you kind of have that laid out. But I think it's interesting to just look at a problem like that and kind of just pause and appreciate how much we've learned over the course of these years. You know what I mean? For example, your graphs of sine and cosine, the period. If you wanted to show that they intersect at pi over 4, the antiderivative, all those pieces. And as we get through this unit, you're going to see even more. Because right now, we're finding area. Next week, we're not going to find area. We're going to find volume. Instead of 2 dimensions, we work 3 dimensions. And here's the crazy thing about the calculus. We won't go any further than that, but calculus isn't bounded by dimensions like we are in the world. You could go ahead and find whatever the volume would be of a 4th dimensional figure. It doesn't care. It might be, how is that applicable? There's lots of situations in real life where you have more than 3 variables. So anyway, take all your notes or homework. I want to show you what you can start on, what you can't. Again, you're going to be given some time on Friday to work. I would not do 3 and 4 yet. I would start with problems 1 and 2. Notice how the graphs are provided for you. And then I would also look at problem 5 and 6. And I would pause there. But I think if you could get those 4 problems done, and then tomorrow we'll kind of be able to do the rest, we'll get another piece ready to go.
Mr. Genster and height. How
Yeah.
do you spell height?
H-E-I-G-H-T.
Right. No, there's.
Lily, you're so dumb.
I've been spelling H-I-G-H-T.
Like sight.
You're
Hey, what is this?
No, I get it. This is part of the problem with the English language. Because if you spell the word high, it is not H-E-I-G-H.
What about sight?
High is H-I-G-H. And yeah, sight is S-I-G-H-T. I'm wondering, why is there an E in there? That would be a good question for the English teachers.
Yes.
I think it's just his handwriting.
So why is it that, we don't spell high like that if we spell height like that?
Because that'd be hay.
I've been spelling height H-I-G.
Hey, that's right, because nay. Nay.
nay.
Okay, good, fine. Then why don't we spell it like that?
That's how I spell it.
That's where I'm at.
It's English language could use a makeover, no question.
People who are learning.
Oh yeah, people who have to learn the English language, it's horrible compared to others.
Actually, a written document.